Yeah, so please, as I've always done, if you can hear me, please raise your hand up. Okay, so yeah, so it looks like quite a significant number of you can hear me. All right, so today we would continue with our discussions on consumer behavior. Um, Basically, I am going to look at how we can decompose the total effect of a price change into substitution and income effect. And once we are done with that, then we will take a numerical example of how you can find the optimal bundle for a consumer given the budget constraint and also the utility function of the consumer. Now, let me warn you here. Um, the content for today um, is not that difficult, but you need to pay attention because I realized that last week or the last time we met, a lot of you were not paying attention, despite the fact that I took my time to go through the graphs and know that some were complaining that they do not understand the graph. And I intentionally did not mind them because I thought I have done my best by taking my time to go through the graph. So today I am giving you a warning. I'm warning you now. Please pay attention. Do not multitask. Whatever. I cannot see you there, so I don't know what you are doing. Some do not pay attention. They might be doing other things whilst listening to me. If you do that, you are not going to understand this. Trust me. If you pay particular attention to me without you doing any other thing, then you will definitely understand what I'm going to do. So please, I am warning you now, pay attention to what I'm going to do. Do not do or do not multitask. Don't do any other thing apart from listening to me and watching what I'm doing on your screen. If you do that, then you will not have a problem with the content of today's class. But if you don't, then sorry, I can't do much about it. Some of you will come back and say that they do not understand everything. I cannot do anything about that. But trust me, if you pay particular attention to me and follow exactly what I'm doing, you will not have any issue. So please take note of that. Because today we'll do some mathematics when it comes to the derivation of the optimal bundles. It will involve some mathematics. And if you do not pay attention, trust me, you won't get it. I know some of you are maths phobia, some are also very good in mathematics. But we will assume that you all don't know, and then we'll take our time to go through it with you. But if you do not pay attention, then there's nothing I can do. Right? Okay. So now let's move on to the two. So now from what we did last week, we now know that if you are using the ordinal approach to consumer behavior, the consumer is in equilibrium when the indifference curve is tangent to a budget line. And at that point, the ratio of the budget line, or sorry, the slope of the budget line is equal to the slope of the indifference curve, right? So that the marginal or ratio of marginal utilities, which is the slope of the indifference curve, will also be equal to the ratio of prices, which is the slope of the budget line. So we discussed extensively this consumer equilibrium the last time we met. And then we went ahead to look at two things, the price consumption curve and also the income consumption curve. So we explain what a price consumption curve. So it's just a line that traces new equilibrium points when price changes, when price of the commodity changes. So we looked at the fact that the shape of the PCC will be dependent on the relationship between the two commodities, whether they are substitutes or they are complement. And then we also look at the income consumption curve. So we said that that is a line that traces new equilibrium points when there is a change in income of the consumer. And the shape of that line also depends on the type of commodity that the two commodities are, whether they are normal goods or inferior goods. So we went through all that the last time that we met. So today we are going to look at the total effect of a price change, how you can decompose that into substitution and income effect. So to explain this, I'm going to switch to the whiteboard to explain the total effect of a price change and how we can decompose that into substitution and then income effect. Right. So let me just quickly switch to the whiteboard. Okay. So I have my whiteboard now. So what is total effect of a price change? So what is the total effect of a price change? So total effect. Okay. So we know that along the demand curve. So let's say this is the demand curve for a particular product where the vertical axis measures price and then the horizontal axis measured quantity. So we have this as our demand curve. So we know that if price is, let's say 10, the consumer purchases, let's say 20. And if price falls to 5, the consumer, let's say, purchases 45. Right? Now, the movement from point A to, let's say, point B. So the difference between quantity, which is 45 minus 20, is what we call the total effect of the price change. So the total effect of the price change. Total effect. Because in other words, we're just looking at how the change in price affected quantity. So quantity increased from 20 to 45. So you can classify that as the total effect of the price change. Another way of looking at the total effect is to use the indifference curve. So let me clear this. So let's say that the consumer has commodity Y on the vertical axis and then commodity X on the horizontal axis. And this is the budget line. And this is the initial indifference curve. And then we assume that the price of X falls. So from the analysis we had last week, we know that the budget line is going to rotate outward when there is a fall in the price of X. So it rotates outward this way. Now note that we've said that in the commodity space, right, indifference curves are everywhere dense. So this new budget line is going to be tangent to another indifference curve in the commodity space. So let's say it is here. Let me put it here. So given this, it means that at the initial equilibrium price, the consumer was purchasing this unit of Y and this unit of X. Right? So with the new price, this is the new equilibrium point. So the consumer is now consuming this unit of Y and that unit of X. So now let's see the total effect of the price change. the fall in price for X has resulted for the consumer to increase consumption of X from X1 to X2. Now this movement from X1 to X2 again is what we call the total effect. So that is the total effect of the price change. Right? Right. So in other words, in simple terms, what we are saying is that if the price is 4 and it reduces or it goes up and you change quantity, the change in quantity is your total effect of the price change. Right. So that is just pretty straightforward. If the price is 10 and I was purchasing 20, now price has come down to 5 and I'm purchasing 45. The effect of the price change is to increase the consumption from 20 to 45. That difference is what we call the total effect of the price change. Okay, so I hope that is clear for everybody. Okay. Now this total effect of this price change can be decomposed into two effects. The total effect of a price change can be decomposed or divided into two effects. So the total effect, which I'll call TE, can be divided into two. And these two are substitution effect so we have substitution effect and then we also have the income effect. So substitution effect and also income effect. Now it is these two effects that work together to achieve the total effect. So the total effect you see is a combination of the substitution effect and then the income effect. So these two put together gets you the total effect of the price change. So what I want to do now is to explain what each of these two effects is. So we'll look at what the substitution effect is, and then we'll look at what the income effect is. Now it is note that it is the combination of these two effects that gives us the final effect or the total effect of a price change on quantity consumed. So let's first of all start with the substitution effect of a price change. So I'm going to clear this. So I want to look at the substitution effect of the price change. So substitution effect of the price change. Good. So to explain it, or to explain this, we're still assuming that we have two commodities, commodity Y and commodity X. Right? The price of commodity X goes down. So PX falls. Right? Now with PX falling, X becomes cheaper to the consumer relative to Y. So PS has fallen, X becomes cheaper relative to Y. So what the consumer naturally would do is to replace the expensive commodity with a cheaper one, right? So that change in the consumption of X, that is as a result of this behavior of the consumer, is what we call the substitution effect of the price change. So the consumer has two commodities, X and Y. The price of X has fallen. X becomes cheaper. So the consumer naturally is going to replace the expensive commodity, which is Y, with X. So that means that X will increase, the consumption of X will increase. So that increase in the consumption of X, which is as a result of this phenomenon, this behavior of the consumer, is what we call the substitution effect of the price change. Right? So you can pick, let's say, Milo and Bonvita. The price of Milo goes down. Milo is cheaper. So the consumer can, or rational thing to do is that, okay, so let me even use a different example. Maybe you might not have a situation where consumer is consuming both Milo and Bonvita. They are all the similar products, but you can say maybe clothing and food. For instance, clothes and food. So the price of food reduces, right? So food becomes cheaper than clothing. So what a consumer naturally would do is that, oh, now food is cheaper. So instead of buying 5 clothes, I will buy 3 and buy more food. So that increase in food consumption because of this phenomenon is what is referred to as the substitution effect of the price change. Now, this is what I want you to know. The substitution effect is always negative in terms of direction of change. Substitution effect of a price change is always negative. So this is what I'm saying. Substitution effect is always negative. It's always negative. Right? The substitution effect is always negative. Negative in the sense that, let me explain. So let's say the price of X goes up, or let me use the reduction. So the price of X comes down. The substitution effect leads to a rise in the quantity of X. So what do you see? You see an inverse relationship. The price of X has come down, the quantity of X has gone up as a result of the substitution effect. So you see an inverse relationship, and that is why we are saying it is negative. If it was an increase in the price of X, then quantity will rather fall. If it was an increase in the price of X, quantity will fall. And again, you see an inverse relationship. Right? So please take note of this. As long as demand is downward sloping, or even if it is not downward sloping, it's upward sloping, whatever it is, substitution effect is always negative. So when there's a price increase, the substitution effect will lead to a fall in quantity. When there is a price reduction, substitution effect will always lead to an increase in quantity. So that is why you have that negative relationship. Substitution effect is always negative. Please take note of that. And I've explained why it is negative. Because when there's a price increase, substitution effect will lead to a fall in quantity. When there's a price reduction, substitution effect will lead to an increase in quantity. That is why substitution effect is always negative. It can never be positive. Right? Okay. I saw a hand up, but it's been lowered. If the person can raise the hand up again, then I would unmute him or her to ask the question. So I have Michael. Michael, go ahead.
Sir, please, with the
Michael, your voice is so down, I cannot hear you.
Sir, please, with the substitution effect, can you
Michael, I still can't hear you. If you can increase your voice. Is it possible to type, Michael? Because we can't hear you.
Can you hear me, sir?
Sorry?
Can you hear me?
Yes.
Can you please hear me?
Yeah, I can hear you now. Go ahead.
Yeah, I said with the substitution effect. Can you still go over again?
Substitution
please,
is
I
what?
didn't get your point. I said, please go over again, please. I didn't get your point.
So this is what I'm
saying.
Michael.
Please use example, please.
I just use maybe you were not with us, Michael. I use an example. So this is what I'm saying, Michael. I'm warning you guys to pay attention. I use an example. If you don't pay attention and know that what the question you are asking me, I have used an example and I know I've explained it well, I will not explain it again. So pay attention, Michael. So let's go over it again. I'm saying that when you have two commodities, X and Y, right? The price of X, let's say it falls. Now, if you have these two commodities, so in relative terms, when the price of X falls, X becomes cheaper relative to Y. X becomes cheaper relative to Y. So what does the consumer do? Naturally, the consumer is going to replace the expensive commodity with the cheaper one. Now the change in X, that is as a result of this phenomenon, is what we call the substitution effect. And I started an example. Let's say clothes and food, right? The price of food has fallen. Food has become cheaper. So naturally what the consumer would do is that if I was buying 5 units of clothing, the consumer can decide to buy 3 units of clothing now and use the money of the 2 units of clothing to buy food because food has become cheaper. So that increase in the consumption of food as a result of this is what we call the substitution effect. So the consumer is substituting because food has become cheaper. And I'm saying that this effect is always negative. It is always negative. Negative in the sense that there is an inverse relationship between price and then the quantity of the good in question. And what you have on your screen is what I used to explain that. So if there is a price fall, the substitution effect will lead to an increase in quantity of the commodities whose price has fallen. And if there's a price increase, substitution effect will lead to a reduction in the commodity whose price has increased. So you look at it from price change and then the quantity change. As long as when one goes up, one comes down, then it is a negative relationship. So therefore, substitution effect is always negative. I hope it makes clear to you now, Michael. Your hand is still up. I have unmuted you, Michael.
Yes, I'm okay now.
Okay. Now let's move on. So that's the substitution effect. But please note this, that in reality or in practice, you don't see the consumer actually decomposing this total effect into substitution. It just happens. But within it, we see substitution effect and we see what income effect, which I'm going to look at now. Right? So this is just theory, but in practice, you cannot say that the change in quantity as a result of a change in price, this change is substitution effect and this change is income effect. What we know is that these two effects put or come together to result in a total effect of the price change. Right? So now let's get the income effect. So the income effect, so income effect. Now in economics, we distinguish between two incomes. We have what we call nominal income, nominal income, nominal income, and then also real income. Nominal income and real income. Now, real income is equal to your nominal income divided by price. That's what gives you your real income. So real income is your purchasing power. So real income is your purchasing power, right? So the nominal income is the income. For instance, if I receive an income of, let's say, 1,000 Ghana a month, that 1,000 Ghana is my nominal income. But if the price of the item that I spent the 1,000 Ghana on is, let's say, 2 cedis, then my real income will be the 1,000 Ghana divided by 2 cedis, which is 500. That's my real income. Okay? So get this distinction, a nominal income and a real income. So real income is your purchasing power. So it's more or less your ability to buy goods, the quantities of goods and services that you can buy. That is your real income. And that's what we are interested in as economists, not just the nominal income. If your nominal income rises by 100% and the inflation also rises by 100%, nothing has changed in your life. You are still where you are. So economics are interested in real income, okay, which is your nominal income divided by the price of the items that you sell. Good. Now, with a change in price, real income also changed. So let's say the commodities again are Y and X. the price of X, and then I is the nominal income of the consumer. So the price of X comes down. And we know that real income is equal to your nominal income I over the price of X. So the price of X has gone down. So it means your real income will go up. The same way, if the price of X goes up, so if the price of X should go up, that way your real income will come down. So please get this. Real income, nominal income divided by prices. So if the price of a commodity that you spend your income on reduces, that means that you have more purchasing power. Your real income will go up. If the price increases, it means you have less purchasing power, and therefore your real income would fall. Right? Okay. Now, changes in real income affords the consumer the opportunity to purchase more or less of the commodity. Right? So if your real income has gone down because prices has changed, you are limited in the quantities to purchase. If real income goes up because prices have fallen, then you can afford more of a particular commodity because your real income has gone up. Right? So the change in quantity as a result of changes in real income is what is referred to as the income effect. So let me get it well. So let's start with a reduction in the price of X. We know that the consumer's real income is going to go up because the price of X has fallen. So once real income goes up, it means that the consumer has extra income to spend on the commodity. Now, this is the effect. Depending on the type of commodity, the commodity we know can be a normal good or an inferior good. We know this. So if the commodity is a normal good, then with an increase in real income, the consumer is going to purchase more of X. So the quantity of X will go up. If it is an inferior good, with an increase in income, the consumer is going to purchase less of it. So the quantity of X comes down if X is an inferior good. The reverse, if the price of X goes up, then we know that real income is going to fall. So real income will fall. And with a fall in real income, If the commodity is a normal good, the quantity will fall. And if it is an inferior good, the quantity would rise. Right? So again, income effect is a change in quantity as a result of changes in the real income of the consumer. And the effect or the income effect will be dependent on the type of commodity, whether the commodity is a normal good or an inferior good. Now let's look at the direction of the income effect. Now, unlike substitution effect, which is always negative, the income effect can be positive or negative, depending on the type of commodity. That is, whether the commodity is a normal good or an inferior good. So it depends on the type of commodity, whether the commodity is a normal good or an inferior good. So now, given this, let's analyze the direction of change for income effect. So I'll pick the first one. Price falls. So when price falls, what happens to quantity? Quantity goes up for normal good. So you see an inverse relationship. So then you can say that for normal goods, the income effect is negative for normal goods. For inferior good, income effect is positive for inferior good because price has fallen and then quantity also falls because the commodity is an inferior good. So for inferior goods, the income effect is positive. You can analyze it this way too. When there is an increase in price, by the end of the transmission mechanism, you see that for normal goods, quantity consumed falls. So the direction, this is up, this is down. Again, a negative relationship. For inferior good, this is up, this is also up. Again, a positive relationship. Right? Now there's something I want you to take note here. Okay, so I have a hand up. Agnes Ejewadapa. Agnes, go ahead.
Yes, sir. Sir, please kindly go over the negative and positive for the normal and inferior good. Hello.
Yes, so let's take it again. The price of X has fallen. So with a fall in the price of X, what happens to quantity when the product is a normal good? Quantity will go up. So you see, this is falling, this is going up. So there is an inverse relationship. And that tells you that if the commodity is a normal good, the income effect is negative. If the commodity is a normal good, the income effect is negative. Then you come to inferior. Price has fallen, quantity has fallen because the commodity is an inferior good. Now look at the direction. This comes down, this comes down. So there's a direct relationship. Again, it is a positive relationship because the price of X has fallen, the quantity of X will fall if X is an inferior good. So you see a positive relationship. We can also do the same analysis using an increase in price. When the price of X rises, real income will fall. The quantity of X, if X is a normal good, will fall. So what do you see? A rise up, a fall. So a rise and then a fall. An inverse relationship. Again, for normal goods, income effect is negative. And then you can look at this for inferior goods as well. You see price has gone up, quantity too has gone up. So you see a direct relationship. And direct relationship means a positive relationship. So the two, with a rise in price, quantity rises for inferior goods. And therefore, that's why we're saying that for inferior goods, the income effect is positive. Now, I was going to make this point that in some textbooks, they analyze the income effect from the perspective of the change in the real income. So please, I want you to take note of this. In some textbooks, income effect is analyzed from the perspective of the change in the real income. If that is the case, then we have the opposite of what I've just said in terms of relationship. So, for instance, instead of analyzing the income effect from the price change, they will analyze it from the real income change. So, if real income should go up because price has fallen, and then quantity for the commodity goes up if the good is a normal good, then here you will say that the income effect is positive. If you are analyzing it from the real income perspective, then you will say income effect here is positive because real income goes up, quantity goes up because the good is a normal good. And then you can also say that for inferior goods, the income effect is negative because real income goes up, this one comes down. That gives us a negative relationship. So if you come to a price rise, real income will fall. So a fall in real income, a fall in quantity for a normal good. So therefore, you will say that if I'm analyzing it from the income perspective, that's the real income perspective, then the income effect for normal goods would be positive, and then it's going to be negative for inferior goods. So please just look at these things when you are reading textbooks. So in some textbooks, you might go and find that it is saying that for normal goods, the income effect is positive. Do not say that the textbook is wrong or I am wrong, but read it and see where the textbook is analyzing it from. If it is analyzing it from real income perspective, then it is right. Right? If it is analyzing it from real income perspective, then of course, real income or income effect for normal goods will be positive, and then income effect for inferior goods will be negative. Okay, so I have some few questions here. I have some messages in the dialogue box. Let me check what the messages are. So I don't know what this person, when price increases, the income effect for normal good is negative. Income effect, whether price increase or decrease, depending on the perspective you are looking at it. If it is a price change, income effect for normal goods is negative, whether price increase or decrease. So it's negative if you are looking at it from the perspective of the price change. And I've explained it in both cases, a reduction in price and an increase in price. You always see a negative relationship for normal goods, income effect. So when price increases, the income effect for normal good is negative. The income effect for inferior good is positive. Now, when price decreases, the income effect for normal good is still negative. Yes. And then income effect for inferior good is positive. So I don't know what you are trying to do. So somebody is asking which you go by. Okay. So for this course, what you have in your slides is the first one. Hmm? So I was going to come to that point. 9:30. What we have in our slides is the first one. Looking at it from the perspective of the price change. But I was just trying to tell you that in some textbooks, so some of you might have go or might will go. I mean, some of you will go and look at, read other textbooks, and they will see that difference. So that's why I'm just drawing your attention to it. But for us, we are analyzing it from the perspective of the price change. So please take note of that. Okay. I saw a hand up. I think Ejewa Dapa hands was, or this is Agnes. Okay. So yes, Agnes, go ahead.
Yeah, it was what you just answered. I wanted to know whether in exams they will specify if we should go by the income
Okay.
effect or the, yeah.
Okay. So like I'm saying in the slides, it is the first one. So stick to that one. But I'm just trying to warn you here. Some I know students will go and read and then they say, Dr. Rahman said it's negative, but we see a positive in the book. Why is that the case? So I'm warning you. So when you check and you see positive, read it and see where which perspective is being looked at. Right? Okay.
Okay, thank you, sir.
All right. Okay. So now it is these two effects. When you combine them, that gives you the, what do you call it? The total effect of the price change. So now let's put them together. Let's put these two effects together. Okay, I have a hand up, Johnson. I have fear. So Johnson, go ahead.
Yes, sir. I want to find out if there is any case where income effect is zero, please.
Sorry?
I want to find out if there is any case where income effect is zero.
You are looking at a case where income effect can be zero. Oh
Yes,
yeah,
please.
we can have that. We can have that. I mean, so in that sense, there is this type of demand functions that we talk about. So we have a compensated demand function. So I am not going to go through that with you. But there are two types of demand function. There's a Marshallian and compensated. Compensated demand function assume that the income effect is zero, but it is beyond the purview of this class. So I'm not going to go through that with you.
Oh, okay, sir. Thank you very much, sir.
Sorry?
Thank you very much, sir.
Sorry?
Yeah, I get you, sir, please. So I'm thanking you, sir.
Okay. All right. So that's fine.
Okay.
Okay. So now let's try and put these things together. So there are three types of goods. So we have a normal good. So I can have a normal good. Okay. And then I have, so let me analyze a normal good first. So if price of commodity X should go up, let's see the substitution effect for normal goods, the income effect, and then we have the total effect. Okay, so for normal goods, with an increase in price, substitution effect you always know is negative. So I'm using the negative sign. So that means that it will lead to a fall in quantity. Income effect is also negative, right? And then the total effect is also negative. So let me say that this goes up, substitution effect will bring it down, income effect will also bring it down, and then this is also down, the total effect. But if it is a price fall for normal goods, substitution effect will bring it up, it is still negative. Income effect will also bring it up, it's negative. And then the total effect also goes up, it's negative. Right? For normal goods. For inferior good, so for an inferior good, price of X goes up, substitution effect is always negative, so it is going to come down, negative. Income effect is positive here, so it's going to come up. Now, the total effect is negative because for inferior good, the demand curve is also downward sloping. Now, the reason why the total effect will be negative is so this one brings it down. So the negative substitution effect here outweighs the positive income effect, so that the net effect is still negative. So what we are saying is that for inferior goods, the reason why the net effect is negative is because the substitution effect is greater than the income effect. That is why you still see the demand curve for an inferior good also being downward sloping. Right? If it is a price reduction, substitution effect will lead to an increase, is negative. The income effect will lead to a reduction, but the total effect is negative, but it's an increase. And again, it's because the substitution effect outweighs the income effect for inferior good. And then we have the last type of good, which is giffen. Remember, I mentioned this giffen good, but I said that in the analysis, we are not assuming that the product is a giffen good. But let's see what will happen if we have giffen good. So if the good is a giffen good, right? So giffen good have upward sloping demand curve. So for giffen good, when price increases, quantity demanded increases. So how does that come about? With an increase in price, substitution effect will lead to a fall in quantity. So it's negative, right? But the income effect is positive for giffen good. So the income effect is positive for giffen good. That leads to an upward sloping there, an increase. However, the total effect is positive, because, so it leads to an increase because the positive income effect outweighs the negative substitution effect. That is why for given goods, when price increases, the consumer will buy more of a given good. Right? And then you can also analyze it for a reduction in price. So if it's a reduction in price, again, substitution effect will bring it up, negative, but the income effect will bring it down. And then you see that the net effect would be, this will be positive. So it's down. And then of course, it means that the income effect outweighs the substitution effect for giving good. But don't worry yourself so much with giving good anyway. But we just need to make a point that it's a commodity, it's a type of commodity that we have. Right. So this thing that I have done here is what you have in your slides. Okay, so let me just switch to the lecture slides. So that's what you have here in your slides here. Although the arrows are not at the places where they are supposed to be, but that is basically what we are saying. So if you pick a normal good, for instance, with an increase in price, substitution effect will lead to a fall in quantity. So the arrow here is for normal goods. And this is supposed to be for income effect, and this is supposed to be for total effect. So please, when you are reading it, do not get confused. These arrows, the last arrows here should be for this last column. And then the middle one is supposed to be for the income effect. And then of course the first one is the substitution effect, so that you can get a direction of change. Right? Okay. Any question on this before I move on to look at the numerical example? Any question on this? So now you know that the total effect of a price change can be decomposed into substitution and income effect. And you should be able to explain what the substitution effect is. You should be able to explain what the income effect is. And also explain the direction of change, whether it's positive or negative. So you know that substitution effect, it is always negative. But income effect can be positive or negative depending on the type of good. For normal goods, income effect is negative. For inferior goods, income effect is positive. Now for inferior goods, although income effect is positive, that positive income effect does not outweigh the negative substitution effect. That is why we still have inferior goods having a downward sloping demand curve. But for given good, it outweighs it. So that's why a given good has an upward sloping demand curve. I have a hand up. So Roger, yes, Roger, go ahead.
So please, with the analysis, talking of the normal good and the inferior good, it's realized that with the substitutional effect, irrespective of the type of good, they still respond to the normal law of demand. But with respect to the income effect, the type of good is what will be determining the effect.
Yes.
Okay. Thank you very much, sir.
Yes. Is that all your question?
Yeah, I wanted to get it like that.
Yes. So substitution effect, that's what I'm saying. It's always negative. Whether the good is a normal good or inferior good is negative. But income effect is dependent on the type of good, whether the good is a normal or inferior.
Okay.
Right? Okay.
Thank you, sir.
All right. Any other question before I move on to the mathematics? Any other question? Okay. So if you don't have any question, then let's move on to the mathematics now. So let me switch to the whiteboard to do the maths. Okay. So let me clear this. So now, one other thing we can ask you to do, and I think we always ask students to do this every year in exams. So after this class, you can start picking, you can start looking at the past question and you find similar questions in there. Almost every year, there's a question on that for students. So I'll urge you to pay much attention to what I'm going to do now. Somebody's asking exams. I think I told you the exams will be face to face. So every year you would have that. I mean every year we kind of set a similar question or a question on that. So please pay attention to what I'm going to do. If you do pay attention, I don't think you will have any issues with it. So what we want to do is graphically, this is the equilibrium of the consumer, right? So this is the equilibrium of the consumer graphically. And then you have, this is the quantity of Y that the consumer will consume, assuming we have Y here, and then we have X here. And so this is the quantity of X that you will consume. So what we are going to do now is to find these values of Y and X mathematically. That's what we are going to do. So we are going to find the values of Y and X mathematically. And to do that, we need two equations. One is a utility function, which is going to represent the indifference curve. So the utility function is the indifference curve, showing that the consumer derives satisfaction from consuming only these two goods, commodity X and Y. And then the budget line, we know that already, which is the budget equation. So Px plus Py times Y. So this will be the two equations that you need. So for exams purposes, at least for this equation, it will be specified for you. This one, in some cases, we specify it for you, but in some cases, we write it in words and you have to set it up. So you'll be told that the consumer income is 200, the price of X is 2, the price of Y is 4. So you would have to set that equation up to be able to work it out to obtain the optimal bundles for X and Y. Okay. Now, before we do that, there's a mathematical concept that is needed for this. So I know some of you might have done elective maths before, and therefore you might know this mathematical concept. But let's try and help those who haven't done elective maths and therefore might not know it to understand this mathematical concept before we come back to solve this mathematically. And that mathematical concept is the concept of derivatives or differentiation. Derivatives or differentiation. Okay? So if I have a function, so I'm going through the mathematical concept, so please pay attention to it. If I have a function that says that y is equal to, let's say, kx to the power n, right? Y is equal to kx to the power n. Mathematically, the derivative of y with respect to x, which is measuring the change in y as a result of a unit change in x, is written as dy dx, right? Dy dx. which is the same as change in y over change in x. Okay? So mathematically, the derivative of y with respect to x is referred to as dy dx, or the change in y over change in x. Right? Now, how do we obtain that? Now, this is the rule. The rule is that if you want to differentiate y with respect to x, it is n times k times x to the power n minus 1. So the derivative of y with respect to x is equal to n times k times x to the power n minus 1. So let's take an example. Let's say y is equal to 2x to the power 3, and you are asked to find dy dx. Then it is going to be equal to 3 times 2 times x to the power 3 minus 1. And that will be equal to what? 6 times x to the power 2. All right? Another example. Y is equal to, let's say, x to the power 4. So the derivative of y with respect to x will be equal to, so 4, note that in this case k will be 1, but we don't write it. So it's going to be 4 times x to the power 4 minus 1, which is what? 3. Right? Now try this. If y is equal to x to the power half, what is dy dx? If you know the answer, raise your hand up and I'll call you, or you type it. Okay, so I've seen a hand up, Saki Folsen. Okay, Saki Folsen. You are unmuted.
Okay, sir.
Yes,
Sir,
go ahead.
please can you hear me? Please, the answer is half 1 over x, 1 over 2x raised to the power half, or 1 over 2 root x.
So 1 over 2x raised to the power what?
Half.
Is it half or minus half?
Sir, please, 1 over 2x raised to the power half.
No. I think you missed something. Okay, so let me call Belinda. Belinda.
Sir,
Yes.
please, is 1 over 2x raised to the power negative half,
Yes.
or same minus half? Yes. Thank
So
you.
it's 1 over 2 x to the power minus half. Person. The reason why it's minus half is 1 over 2x to the power 1 half minus 1. So half minus 1 is minus 1, minus half. Right, person? Okay, another one. What about this? Y is equal to 4x to the power half. So who knows the answer? I can see another hand up. Dennis. Dennis.
Sir,
Yes.
the answer is 2x raised to the power minus half.
Okay. So that's the answer. So it's going to be dy dx is equal to half times 4, right, times x to the power half minus 1. So when you simplify it, so you have 2x to the power minus half. Good. Now let's make it a little bit complex. So let's say now you have u is equal to y times x. Find du dy or dx, sorry. What will be the answer? Let me see those who are not rigid in learning but flexible. Those who are flexible in learning. So raise your hand up if you have it. Okay, I can see a hand up. Gladys. Gladys Yeboah Mensa. Is it for this or another one? Okay. So Gladys. Hey. Okay, Muji Bat. Muji Bat. Muji. Okay, Muji. Muji, go ahead.
Yx raised the power negative 1.
Sorry?
Yx raised the power negative 1.
Yx to the power 1.
Negative 1.
Hey, I'm afraid, Muji.
Hmm.
It's not right, but let me see. Let me get some other people. Okay, I can see Dennis. Dennis, your hand is up. Go ahead.
Sir, the answer is y.
The answer is what?
Y.
1.
The answer is y.
Y. Okay, so
Yes.
Dennis says it's Y. Let's see any other different. Is there a different answer? I can see some hands up down there. Let me check. Okay, so I have Sadiq. 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 Unmute yourself and talk. Oh, she's gone. Okay, I think I have Joseph. Joseph Dankwa Smith. Joseph. Joseph.
It's Y.
Okay, Joseph also says it's Y. Okay. So yes, it's true it's Y, but let's see why it's Y. So now, if you have two variables like this, and you're asked to differentiate with respect to one, assume that the other one is constant. So in this case, in your mind, this should be K. And therefore, if you are differentiating this with respect to K, so it would have been just like, let's say Y is equal to Kx. So in that sense, the answer will be K. The reason why it's K is that this X is to the power 1. So it will be 1 times K times X to the power 1 minus 1. And this is 0. Any number raised to the power 0 is 1. So that's why you have K. So the answer here will be Y. The same way, if you're asked to differentiate U with respect to Y, then you would have the answer as X here, right? Let's get 2 more examples, then we can go on. So now, assuming that you have U is equal to 2y x to the power half. find du y and also du dx. So who will tell me the answers? So find du dy and also du dx. You raise your hand up and then I'll call you. So I have a hand up. Dennis, is your hand up or it was the earlier one? Okay, so I have Agnes' hand just went up. Agnes.
Du dy is equal to x raised to the power negative.
You mean the u dy?
Yes.
X to the power minus.
Yes.
No, I don't think so.
Minus half.
No. You are differentiating with respect to y.
Okay.
If you are differentiating with respect to y, assume that all other variables are constant. So it's not right. Let me see some other hands that are up. Okay, I have Eric. Eric is new. Eric.
Sure.
Yes, Eric. Go ahead, Eric.
The du dy is equal to yx raised to the power minus 1 over 2.
You mean the u dy?
So the u dy is equal to yx raised to the power 1 over 2.
I'm afraid not. I'm afraid,
Yes,
Eric,
please.
it's not correct. I'm wondering why you people are getting these answers. Okay, so let me check message. Maybe somebody says the whiteboard is not showing on the screen. If it's not showing on your screen, then it's your internet. But please, can you see my whiteboard? If you can see my whiteboard, just raise your hand up. Okay, so the person who cannot see, it's your internet. It's not coming from us. It's not coming from me. It's your internet. Okay, so please, let's get this. So I'm saying that if you are differentiating it with, okay, so I think somebody has gotten, if you are differentiating it with respect to y, assume that all the other variables there are constant. So if it with respect to y, then I'm going to have 2x to the power half, right? Because you see, I'm going to assume, so it's going to be assuming that the 2x to the power half is a constant. So you say that 2x, so it would have been the power of y, which is 1. So it's going to be 1 times the 2x to the power half times y to the power 1 minus 1. And this is 0. So you are left with just 2 to the power half. So please take note of that. So it has to be 2x to the power half. And then when you are differentiating with respect to with respect to x, so you assume that the y, these ones are constant. So it's going to be half times 2y, right, times x to the power half minus 1. So then you simplify. So this 2 is going to be y. So it's going to be y x to the power minus half. That would be the answer for this one. Okay, the last one. U is equal to y to the power half and then x to the power half as well. Find du dy and also du dx, and tell me the answer. So if you know it, just raise your hand up. If you know it, just raise your hand up. Okay, so I have some hands up. I have Godfred Ahmed Kreku. Godfred, go ahead. Oh, your hand is down. Okay, I have Agnes. Agnes, go
Sir,
ahead.
sir, please, the previous example, I didn't get it and we moved on.
Oh, but me, I've deleted it now. So when you get the recordings, then you look at that.
Okay.
Right. So, but do you try this one? Try your hand on this one. It's similar to this one. Okay, so I have Patrick Amo. Sorry. Patrick.
1 over 2x raised to the power half, y raised to the power negative half.
For which one?
The du dy.
Du dy, you get what?
1 over 2x raised to the power half, y raised to the power negative half.
1 over 2x to the power
half,
y to the power
y
what?
to the power negative half.
1 over 2, yes. So it's going to be, this is going to be, so I'm differentiating it with respect to y. So assume that this is constant. So it's going to be, y will be 1 over 2 times the constant, which is x to the power half, and now times y to the power half minus 1. So that gives you minus 1 over 1. 1 over 2. Okay, so minus 1 over 2. And then this will also be half, that's the same thing. So half y to the power half times x to the power minus 1 over 2. Right? That's how it's going to be. Okay, so now I think we are ready to go and answer the questions now. So let me clear this. So let's start with, so this is the utility. So now if you have a utility function of this form, x is a function of, the utility is a function of x and y, and then the income constraint px times x, and then py times y. So to find the optimal bundle, note that the equilibrium condition is that marginal utility of x over marginal utility of y should be equal to the price of x over the price of y, if you remember. So this was the equilibrium condition we had. This is where the budget line is tangent to the indifference curve, right? So you call this equation 2, and let me call this equation 1. So to obtain x and y, solve equation 1 and 2 simultaneously, and that will give you the value of x and y. Now, MUX is du dx. That's what gives you MUX. And then MUY is also du dy. right? So you can easily find the MUX and MUY from the utility functions, and then you substitute. So let's take an example. Let's take an example. Okay, so let's take an example. So let's say you have this specific utility function. Utility is x times y, and then the constraint is, let's say 200 is equal to 4x plus 5y. This is our utility function. And you are asked to look for the optimum level of x and y. In other words, find the quantity that would result from this, where the indifference curve is tangent to the budget line. So x1 and that. So this is x and this is y. So you have to find this. Right? You have to find this. So if that is the case, then let's go and do it. So we know that at equilibrium, the marginal utility of x over the marginal utility of y, marginal utility of y should be equal to the price of x over the price of y, right? So you also know that mu x is a derivative of u with respect to x. And you know that muy is du dy. You know it. So you just find. So mux, so you differentiate this. This will give you y, and this will also give you x. Right? So at equilibrium, y over x should be equal to, now what is the price of x? The price of x is 4. And the price of y is 5. Right? So now you have these two equations. This is, you call this equation 2, and then the budget constraint will be equation 1. So you are going to solve these two equations simultaneously. So there are many ways of doing it. Now this is how I normally approach it. I normally do a cross multiplication here, so that I have 5y is equal to 4x. Okay. Then I can say that y is equal to 4 over 5x. Okay. So it means that wherever I see y in this equation, I should put 4 over 5x there. So once I have that, then I'll go. So I have 200 is equal to 4x plus 5 into bracket 4 over 5x. This is what I have. So this is the y. So this will cancel that and cancel that. So that I have 200 is equal to 8x, right? So therefore x is equal to 200 over 8. And what is the answer? So you divide 200 by 8. Is it 25? So you have a 25. Now, if x is 25, you can easily find y. We know that y is 4 over 5 times x. So 4 times 25. So this will be 100 over 5, that will be 20. All right? So that means that at this one, x here will be 25. This will be 25. And this will be 20. That's what this is named. Okay, let's do it again. Let's take it again. So yeah, the utility function is u is equal to x, y, and then the budget constraint is 200 is equal to 4x plus 5y. So you know that at equilibrium, marginal utility of x over the marginal utility of y should be equal to the price of x over the price of y. Now, marginal utility of x, again, is the derivative of u with respect to x. And then from that, you see that it's y. And then the marginal utility of y is a derivative of u with respect to y. So you see that it's x. So it means that this will be equal to y over x is equal to, now the price of x is 4 here. And then the price of y is 5. So these are the two equations. So this is equation 2 and this is equation 1 that you are going to solve simultaneously. Now, like I said, there are many ways of doing it, but this is the approach I normally use. You can stick to that approach or you use a different approach. Whichever way, the most important thing is that you are solving those two equations simultaneously. So this is the approach I normally use. I do cross multiplication here. So I have 5y is equal to 4x. Then I make one of them the subject here. So I do y is equal to 4 over 5x. So I can call this equation 3. So once I know this is y, I'll go and substitute it in the constraint so that I have 200 is equal to 4x plus 5 into bracket y, and then y is a 4x, a 4 over 5x, and then you close your bracket. So this 5 will cancel this, and therefore you are left with 200 is equal to 4x plus 4x, and that is 8x, and therefore x is equal to 200 over 8, and that's what gives you the 25. Now, once I know x, I can easily find y because I know that y is equal to 4x over 5. So, and then x is 25. So you just put it there and then you work it out. So y is equal to 20. Right? Now try your hands on this and let's see. I see a hand up, Agnes. So Agnes, go ahead. Agnes, go ahead.
Yeah, so please, I wanted to know how to conclude.
How to do what?
With the conclude your answer. Find the optimum. So you just go straight at the optimum level is this.
How to do what?
Conclude your answer. Do you just state that y is this and x is
Yes.
this?
So if the question is asking you to find the optimal levels of X and Y, so you say Y is 20, the consumer will consume 20 units of Y and then 25 units of X to maximize his satisfaction. Right? Okay. So now I'm saying, let me just warn you here. In the exams, you will not see, it might not be just X and Y. It might not be X and Y, but it will be a commodity. It could be clothing and food. It could be orange and apple and all that. You just have to know how to manipulate it, right? I am using X and Y. So X stands for one commodity. Y is also another commodity. So whichever commodity you are given, if it is food and clothing, then you know that there's a marginal utility of food divided by marginal utility of clothing should be equal to the price of food over the price of clothing. If it is apple, you say the marginal, if it's apple and orange, it will be marginal utility of apple divided by the marginal utility of orange, and that should be equal to the price of apple over the price of orange. So irrespective of commodity that is given to you, you should be able to do it. Why? We do it here using X and Y to represent commodities. That's all. So it's the same principles that you use. I have a hand up, Edmond. So go ahead, please. Hello.
Please, I want to ask, maybe I'll say let Apple be equal to X.
Sorry? If
I said I want
let apple equal to X, let orange be equal to Y, you are dragging the whole thing. It will be disturbing us when we are marking. You can use apple and what do you call it? You can decide not to. I'm wondering why you students are so rigid in learning. You want to convert it to X and Y before you can work it. Even if you don't convert it to X and Y, you should still be able to work. But if you want to do that, that's fine. It just means that if the marker is in good mood, but if it's not in good mood, just give you 0. But you can do that anyway. So
okay.
Yeah.
Okay.
So let's try this example. Try it on your own. Then we would conclude the class. So let's say you have U is equal to 2YX, right? And then the constraint is 100 is equal to 2x plus 3y. So find y and x that maximizes. That maximizes utility of the consumer. Utility. Right, so do it. Let me give you 5 minutes to do this. I'll come back after 5 minutes. So do it. I'll come back after 5 minutes to check the answers that you have. But I saw a hand up. Let me see if the person still has a hand up. Okay, Roger. Okay. Roger, go ahead.
Yeah, please. You were about giving a warning in exams, and my network got off. So I wanted to know the warning you wanted to give in the exams.
I'm saying that in exams you might not see X and Y, but you might see other commodities like maybe food and clothes, orange and apple. You should still be able to do that. The X and Y is just to represent commodities. So if it is orange and apple, then you work it in this. So it's going to be marginal utility of orange divided by marginal utility of apple should be equal to the price of orange over the price of apple. And then you work. So irrespective of what is given to you, this X and Y are just symbols to represent commodities. That's okay. So work this one out and then I'll come back in 5 minutes to check your answers. So I'll be back in 5 minutes. Okay, so I'm back. Who has the answer? Okay, so I've seen some hands up. Let me go and check. So I have Benedict Opari. So Benedict. Benedicta.
Yes, sir. Sir,
So go
X equal
ahead.
to 25. X is 25.
We are
And
getting
Y is,
feedback, so it looks like you are using two devices. So it's giving us feedback.
oh, you can hear me now.
Oh no.
Wow.
Patrick Amo. Oh, Patrick Amo. Sorry. Patrick Amo.
Yes, sir, please. X is 25. Y is 50 over 50 divided by 3.
You got X to be 25.
Yes, and Y 50 divided by 3.
50 divided by 3.
Yes, please.
Okay. Let's see if there's any different answer.
That's 16.7.
Sorry?
The Y will be 16.7 in decimals.
Okay, all right, that's fine. So let me check knee boy. Knee boy.
I got X 37.5 and Y 25.
You got X to
To be
be
37.5,
okay, and then Y is what?
25.
25. So yeah, we have a different answer here. Oh, I see where probably you went wrong. Okay, all right, that's fine. Let me see. I have Mr. Amo Andrews entry. So Amo Andrew, you are unmuted. Go ahead.
I had
Please, if you are using two devices, it will be giving us feedback. So you have to put one off.
X to be 33.33 and then Y to be 11.1.
You got Y as well, 11.
Charlie, increase America, yeah.
Let me go to Stella. Let me go to Stella. Okay, so let me get Stella, then I can check. Stella.
Hello, sir.
Yes.
Sir, please, I had X to be 25 and Y 37.5.
Okay, so X 25, Y 37.5. Okay, all right. So now let's confirm the answers that you have. I think I have a number of them now. So let's confirm the answers that you have. So it has to be marginal utility of X over marginal utility of Y. Now note that you can also actually make it marginal utility of Y over marginal utility of X. But in that sense, it will be the price of Y over the price of X. So whichever way you want to do it should be equal to the price of X over the price of Y. Right? Okay. So now let's get the marginal utility of X. Marginal utility of X will be 2Y. And the marginal utility of Y will be 2X. So these ones will cancel each other. So I have 2 over 3. So I can do my cross multiplication, where I have 3y is equal to 3y is equal to 2x. So therefore y is equal to 2 over 3x. All right. So now let's go and put in where we find y as 2 over 3x. So I have 100 is equal to 2x plus 3 into bracket y is 2 over 3 x. So the 3's will cancel. This will cancel that. So that you have 100 is equal to 4x. Right? So therefore x will be equal to 100 over 4. So x is 25. So you get x as 25. So now let's find y. If you get the same y as right. So once I know x, I can find y. So y is equal to 2 over 3 times x. And the x is what? 25. So I'll have it as 50 over 3, as someone said. Or you get a 16.667 or so. So that's the answer. So those who got 37.5, I suspect you did, when you were substituting, you forgot the 3. That's why you got that. Yeah, so the y will be, if you divide 50 by 3, it should give you, so you get 16.667, right? So that's how you solve it. Okay, so now, like I said, almost every year. Why did I use 2 over 3? But that's what I got here. Maybe you didn't follow me. So if I have 3y equal to 2x and I make y the subject, if you make y the subject, then you have 2 over 3x. So wherever I see y in the constraint, I'm going to put 2 over 3x there, and that's what I did. Right? Okay. So like I was saying, in any of the past questions, you find this question of optimization there. So start trying your hands on them. The question will not start straight away to say find the optimal bundles. It will start, okay, now specify the budget constraint. Then you specify it, draw it, then you draw it, and then it keeps on going until it's so that at some point it then asks you to find the optimal bundles for X and Y. So you combine everything that we have learned so far together to answer that question. Okay, so there are so many of that questions in the textbooks. You can in the exams. So try your hands on them. If you have any difficulty, you can send me an email and then I'll be able to help you. Okay, so that brings us any question? Any question? If you don't have any question, then we can end today's class. We've even gone over our time. Any question? All right, so in the absence of a question, I'll call the class. I'll call it a day. Oh, I've seen some hands up now. I don't know. It was a knee boy. I'm sure it's the earlier one. Stella earlier. Roger. Okay, Roger is a new one that I've just seen. Okay, Roger, go ahead.
In terms of finding do we say that the denominator is the value of the final answer? In terms of finding the value of the derivative, that's the x over dy.
Yeah.
Do we say dy is the value that we will get after calculating using the formula that you taught us?
I don't get your point, Ashon.
Please, you see that dx over dy. When we were finding the first equation, we said that the dx over dy is equal to x. That's the previous one that we solved.
Yeah. You mean the marginal utilities? You mean du? It was not dx. Du over dy. It's du dx or du dy.
Okay. I get it.
They are marginal utilities,
I
not
thought
dx.
it is dy dx and du dy because the u was looking like a y.
Yes, those the examples that we were doing earlier. But when it comes to utility, then it is u. So you differentiate the utility function with respect to u x or with respect to y as well.
Oh, okay. Sir. Thank you, sir.
Okay. Definitely, Hamdiat, you will definitely get it, and I always send it to you. I don't know why you're asking. Mashoot, Hamdia, Hamdat too. You always get it, so I don't know why you are asking if you can get it. You always get it. I send it to the class repo, so there it's always there. Okay. All right. So have a good afternoon. Bye bye.